you want to move this up? Any questions on anything I did there? I know I rambled through the end of it there. Yes.
In part two it said draw a graph from AN against N. Does that just mean in the domain of like 0?
They told me in the domain from 0 up to 10, didn't they?
Yeah.
Right.
That's just what the question means though.
Yeah, it just means use N is 0 and N is 10. So I actually drew it more because I put in a 12 as well because I had the values for 12.
Yeah.
But I didn't bother making up any new values because I had 0 from part 1 and I had 10 from part 2 and I had 12 from part 2. So I had 3 points already. So I just used those 3 points and I know it's an exponential graph, so I know it's curving up. Is that right? Yeah. So I didn't get any new points. Yeah. You could get new points there. You could go after your calculator and get all the points between 0 and 10. Right, okay, but there's no need because you have 3 points already. That was my point. Right, okay. And the doubling time, girls, right, it started at 1,000. I know that from part 1. So when it doubled, if it started at 1,000, it doubled, it was double at 2,000. So I just went across at 2,000 and went down to see how long did it take to go for it to get to 2,000, and the answer was 5 weeks. Okay, I could have went across at 4,000, it's 10 weeks, and at 2,000 it was 5 weeks. So 10 take away 5 would be 5, right? I could have done cross at 3,000 and you probably get 7 weeks, I don't know what you get, and 6,000 go across and go down and see what you get and then subtract them. Okay, but the easiest one was obviously 1,000 to 2,000. Is that alright? Yeah, will I go?
Can you push it down a small bit?
Oh, sorry. Yeah, that's it. Right, okay. If I do this, am I okay? I haven't cut anyone off, have I? Will I move it up again? Am I okay? If I cut anyone off, that's it.
How do you know you can double time?
Sorry?
How do you know you can just double?
Because they asked for the doubling time. So that means how long before it doubled in area. Right, okay. So I did 1,000 and 2,000. Yeah, because it starts at 1,000. So I said double 1,000 was 2,000. So I just went across at 2,000. Right? But you could use, yeah, it said use the graph. Yeah, the question said use the graph. Okay? Right, we good? No?
What are the numbers on the bottom of the line?
Sorry, 2, 4, 6, 8, 10. Yeah, I can see why you can't read them. Sorry. It's 2, 4, 6, 8, and these are the number of weeks. Okay, so 2, 4, 6, 8, 10.
And then above it is
2,000, 4,000, 6,000, 8,000. Right, okay, and that's the area in terms of N. And I used 3 points to draw the graph. I used my answer from part A, or from part 1, right? And I had 2 answers from part 2. I had at 10 weeks it was 4,000, and at 12 weeks, even though they didn't ask me to draw, they only asked me to draw it from 0 to 10. I know I have another point there at 12 weeks, okay? And I use those 3 points to draw the graph. Is that right? Okay, I could have got some more points in there in the middle, but yeah, I think I've enough with 3 points because I know it's an exponential graph, so I know it's just going up. Is that right? Right, okay, I'm going to do a second example. Can I take this away? No?
Is there 4 parts of that?
Yeah, that's part IV there. It says doubling time is 5 weeks. So that was the question. How long does it take to double an area? So it doubles an area every 5 weeks. And how did I know? Because it started at 1,000 and I said double 1,000 was 2,000. So I just went across, hit my graph and went down and read off the number. So it's halfway between 4 and 6, so it's 5. Now my graph is very accurate. If you were drawing your graph, it would be a lot more accurate. It would be on graph paper, etc.
Will they be quite lenient?
No, they'll just whatever, yeah, they'll give you squared paper if they want you to draw a graph, and whatever your graph says is the right answer. Okay, right, okay, am I good? Right, okay, so I'm going to show you question 9 now, which is the next one I'm going to do, right? So it's in the book also. Again, you can see why I'm not writing it out, because it's just way too long. Right, okay. So I thought I might do 8 to start with, but then it's an entomologist again, so I decided that I should do something different. So the pulse rate of a runner, right, so someone's running T minutes after he finishes training. So that means the minute he finishes training, the clock starts. Okay, so he's doing his training and then the clock starts. So he starts taking his pulse. Right, do you think his pulse is going to come down or do you think it's going to go up? He's finishing training. Yeah, it's going to start off really high, isn't it? Because he's after training and it's going to slow down. Would you agree? Right, okay. Pulse rate after finished training is given by, there we have his pulse, is 90 multiplied by 3 to the power of minus 0.25 t plus 50. Right, okay, and look, they told me in the question that t is measured in minutes. Okay, is that right? So t is measured in minutes. That's really the only thing you have to keep an eye on. Right? Sketch the graph of p of t using the values t is 0, 2, 4, 6, 8, 10. Right, okay, so I shall do that first. Okay, so it's p of t, yeah. So it says p of t, so that his pulse is equal to 90 multiplied by 3 to the power of 0.25 t. Yeah. So if you listen for I'll give you a chance to take it down in a minute, because it won't make sense unless you listen, because the questions in the book and here. So it says sketch the graphs, right? It says take the values that t is 0, t is 2, t is 4, t is 6, t is 8, and t is 10. Right? I might need your calculators there for this. So the function is p of t. Now, do you know how to put these functions into the graph or into your calculator? Do you remember? No, right, I'll just show you so.
What do we go about it with fractions, or is it the same? Not fractions, are we?
0.25, it's actually minus 0.25 t, sorry. Right, okay. Can I show you how to put this into the calculator? Okay, so, right, I'll magnify. So this is We can't put t into the calculator, so we put in an x if that's all right. So remind you how to do this. Okay, so you have to put your functions, your graph in function mode. Okay, so press mode, right? Okay, across the top you want table, right? Okay, so across the top you want table. It's number 3. It depends whether you have a new calculator or an old calculator. Do you have the option button on yours? No? Yeah, the newer ones have an options button. It doesn't matter. It's just, I just want to know who I'm explaining to. A mixture of both, is it? Right? Okay, so number 3 is a table, so I'm pressing number 3, right, for table. Right, then it gives me the option to write in f of x equals, right, okay, so f of x, so you just type this, 90 multiplied by 0.3 to the power of, that's x with the rectangle, to the power of minus 0.25. As I say, we can't put in t, so put in x, which is over the close bracket. Do you remember this from Junior Cert? So it's alpha and the close bracket. We'll get an x in there for you. Right, okay. And then just bring off your cursor, bring it down from the index. So if you use the over arrow and you do a plus 50. Is that okay? So that has your function in. Are we all alright with that? So that's what it should look like when it's in. Because it's longer than the then you can see there's a 90 multiplied by there at the start. Okay, so it's 90 multiplied by 0.3 to the power of minus 0.25 x, and then bring down your cursor so you can do a plus 50. Are we all got it? Right, equals, right. Now if you've the new calculator, it'll ask you, do you want to put in a second function, and I don't, so you just enter past that, so just equals past that. Okay, if you've the old calculators, it won't give you an option, so it's fine. Right, then it's start, okay, so I want to start it, look, t is 0, I want to go from 0 up to 10. So t is 0, right, so the start is 0, enter. The end is 10, enter. Now, this is the extra bit from Junior Cert. At Junior Cert, it was going up in 1s, so it was step 1. Right, but this is going up in 2s, isn't it? Would you agree? Look, the x's are going 0, 2, 4, 6, 8, 10. So it's going up in 2s. Yeah? So I'm going to go step 2, as in the steps are 2. Right, okay? Now, you could do step 1 and just write down every second point. Right, but just so you know, that's what step means. In Junior Cert, I would have told you it's always step 1. Right, okay? Leaving Cert, it can be step anything you want it to be. Right, equals, right, and then, what the hell, yeah, equals, right, then all your points will come up, right, okay, so my points are 0, 140, this couldn't be right now, because I've done something wrong now, haven't I, because these are all going up, it should be coming down. What did I put? What did I put? Sorry? It's 3 to the power of minus point. I didn't put that, did I? Do you know, did you all put in the right thing? Will you just give me the right points? 0 what? 0, 140. 2, what you get? Yeah, I must have wrote up the wrong thing, did I? Did I put 0.3 in instead of 3? Right, okay, right, sorry. So f of x is 90 multiplied by 3. Oh, multiplied by 3 to the power of minus 0.25. Oh, for God's sake. Sorry. That couldn't be right because his pulse is coming down. What? We're writing something wrong in. Yeah. 90 multiplied by 3 to the power of minus 0.25 alpha x plus 50 yeah, okay, it's 101.9. Yeah, what's wrong now? Yeah, okay, right. 380. Are you getting this in? Or 480? 101. Right. 67.3 for 6. Right. 860, and then 10, 55.7, 55.8, right? Is that okay? Right. Yeah. Okay, so that's what I typed it in wrong first, right? When you type it in right, that's what you should get. Did you get that? Yeah, right, good. Right, okay, right. Graph, okay, so that I have to go up to 140, right, okay, so I'm just going to, and it's a guy's pulse rate, and it's time on the x-axis, and it's pulse rate on the y-axis. So this is his pulse, this is the time. I have no negative numbers because you can't have negative time and you can't have negative pulse because he's going to be dead. Right, okay? So 2, 4, 6. I know you're laughing, but you know, I'm just like, you have to kind of think about what you're doing. You'd be amazed the amount of people that draw your graph with negative pulse. Right, okay? So I'm going up to 140, so I'll go 20, 40, 60, 80, 100, 120, 140, so it's 0, 140, right, it's 101.9, so that's 102, so a little bit past 100. Right, then he 480, 480, 667, so 68, a little bit less than 70, so it's there. Right, 860 and 1055 point something, 1055 point is about there. Okay, so it starts at 140. It's an exponential curve. It's decreasing, as in it's coming down, right? Okay, it's heading for a line. We don't know what the asymptote is yet. It's heading for a line, so it's heading for somewhere, but it's never going to get there, right? Okay, so it's heading for something, a line there, but it's never going to get there. Okay, I'm going to have to figure that out in a minute, right? But I'll do it in a minute, right? Okay. The questions are then, right, find the pulse rate immediately after finishing training. So the pulse rate, part 1 or part 2, part 1 is draw the graph, part 2 is what his pulse rate immediately after finishing. At the point where he starts measuring his pulse, right, what's his pulse? 140, isn't it? Immediately after finishing is when time is 0, because that's when he started the watch. Okay, right, part 3. Right, How long did it take for his pulse rate to drop to 70 beats per minute? Now I'm using my graph to do this, right? There is a way of doing it using algebra, but that's the next section. Okay, so for the moment, the only way we have of doing this is with the graph. Okay, so you want 70. So at 70, you draw a line across.
Listen, that's 20 and 40 is the last two numbers on the graph.
120, 140. Okay, so draw a line across at 70, draw a line down. Okay, try and draw it on the, oh Jesus. Okay, I've scribbled all over my ruler. That's somewhere between 4 and 6. It's more than 5. It's not 5.5, so I'll say, so 70 beats, I'll say about 5.4. And the time is in minutes, so 5.4 minutes, I would say. That's according to my graph. Now your graph might be slightly different, but whatever your graph says is the right answer. Okay, that's the way it is with graphs. You draw the graph. If you draw the graph wrong, you get penalised at drawing the graph. But if you answer the questions, if that's what your graph says, that's the answer. Right, B was 55 beats per minute. So 55 beats per minute. So 55 is halfway between 50 and 60, so about here. Draw a line across, hit the graph, draw a line down, and there my graph says 10 minutes. Right, okay, but whatever it is, it is. Is that alright? Okay, 10 minutes. What is the runner's normal pulse rate? Okay, now the only way we have of figuring this out at the moment is, right, okay, his pulse rate is slowing down and slowing down and slowing down, isn't it, as he stops the exercise. Let's think about what he's doing. Is his pulse rate ever going to slow down to 0? No. It's going to slow down to a certain beat, isn't it? It's going to stop. Would you agree? Right, okay. So as you see, this is the asymptote, so it's heading for, right, it's heading for this line, but it never gets there. So the best way to do this is, right, this is after 10 minutes. We did beats after 10 minutes. So after 10 minutes, the beats, I used it to draw the graph. Okay, his pulse was, after 10 minutes, his pulse was 55.8. Right, after 20 minutes, right, I'm going to put his pulse in as 20 and just to see where it goes. Okay, so it's 90. Oh no, I'm still at functions. One. So 90 multiplied by 3 to the power of minus 0.25 by 20, which would be 5, wouldn't it? 0.25 by 20 is a quarter of 20 is 5. Add 50. $50.37, I think. Right, okay. After 30 minutes, I'm also going to see where it goes. Right, okay. And it's basically going to be heading, it's going to be a bit nearer 50. It's still not going to be there. So his normal pulse is where he's heading for. Right, so I think it's going to be heading for 50 all the time. Right, okay, so you keep it heading for 50. So at normal pulse is 50 because it's heading for 50. Is that okay? Okay, am I out of time? Is that why you're all packing up? Yeah? I am. So page 484, let's do 4 to 8. So page 484, question 4 to 8.